This is Knowing the Universe, the History and Philosophy of Astronomy. I'm Professor Impey, Distinguished Professor of Astronomy at the University of Arizona in the Department of Astronomy. And in this module, we are going to look at evolution, geological and biological, and astronomical. We'll start with cyclic time, because that's the original form of time that human cultures evolved, as we saw in the module on calendars. Linear time is where the past is behind us and the future is in front of us. That's very familiar. In cyclical time, the future is behind us and the past is in front of us. It almost reverses the logic, and time, of course, may repeat. There are cycles of time over recorded history, and we've seen many of these had to do with astronomical cycles. Most cultures, independently of each other, conceived of time as cyclical. And it's pretty clear, even though we don't always have a written record, that this is because of astronomical cycles. And so here we see in two cultures on different sides of the world, the Buddhist culture in Asia and the Mayan culture in Mesoamerica, cyclic time being central to the way they think of the world they live in. There's a set of astronomical cycles that humans have been tracking as well as they could ever since we have been anatomically modern, so for the last tens of thousands of years. These cycles were tracked to regulate their lives, to track the seasons, to migrate, to follow food sources, and they could be measured in an amazing variety of timescales. And some cultures knew most of these timescales. We have, of course, the spinning Earth on one day giving us day and night, the orbiting moon giving us a lunar cycle of 29 days, the orbiting Earth around the Sun with its axial tilt giving us the seasonal cycle of 365 days. Then the more subtle and longer-term cycles involving the intersection of the Earth, Moon, and Sun orbits lead to the eclipse cycle on about 19-year timescale. There's also a precession of the tilt of the Earth as it's inclined towards the Sun but pivots around the sky like a spinning child's top. This equinox cycle has a period of almost 26,000 years. And then there are even more subtle variations in the Earth-Sun orbit, variation in the orbital tilt, which affects the strength of the seasons on a timescale of 41,000 years, and in the eccentricity, or deviation from circularity of the Earth's orbit, on a 100,000-year timescale. Finally, there's a motion in and out of the Milky Way of the entire solar system, which is imputed in some of the mass extinctions in history, and that has a periodicity of 35 million years. There are circadian rhythms, of course, governed by the Earth's spin, day and night, and the living creatures that respond to day and night, the darkness and light, and also the temperature variations that go with that. Without the Earth's axial tilt, there would be no seasonal cycle, and so, in practical sense, no reason for years. Here we see a visualization of the Earth-Moon-Sun system, and we can see that it's the 23.5-degree tilt of the Earth's spin axis inclining towards the Sun during half of the orbit and away from the Sun during the other half of the orbit that gives the seasonal cycle. If the Earth had no axial tilt, the illumination at any point on the Earth's surface would always be 12 hours day and 12 hours night. And although there would be a difference in the solar illumination between the poles, more glancing sunlight, less strong, and the equator, sunlight directly overhead and so stronger, there would be no seasonal variation. In other words, there would just be strong extremes between the climates at the poles and the equator, but no variation throughout a 365-day period. We've also found, and people discovered this through time in many cultures around the world, an eclipse cycle. It was called the Saros cycle, named after Babylonians and Egyptian eclipse records, and they tracked very clearly a 19-year cycle that's been predicted quite accurately for over 4,000 years. There are also orbital cycles to do with the way the Earth behaves in its orbit of the Sun. The axial precession, shown here, has a cycle of 28,000 years. The direction of the Earth's spin has not always been towards Polaris, and so that would have been noted by ancient cultures who especially used the pole star to navigate. There is also a more subtle change in the obliquity, or the tilt of the axis, on a time scale of about 40,000 years. This, of course, will affect the strength of the seasonal cycles. As the tilt becomes slightly more, the seasonal cycle strengthens, the seasonal variations become more extreme, and as it becomes less, the seasonal cycle moderates or becomes less strong. And finally, there's a change in the shape of the orbit due to gravitational interactions between the Earth and the Sun in its already elliptical orbit by about 4%. This changes subtly on a timescale of 100,000 years. And there's indications, this set of cycles are called the Milankovitch cycles, after the geoscientists who first studied them about 50 or 60 years ago. These three long timescale changes in Earth's orbital dynamics are now implicated quite strongly in a correlation with the Earth's ice ages. So even though they're quite subtle, we do think they can profoundly affect the Earth's climate. And the last motion is quite profound and also very long time scale. This is exaggerated, but the Earth is in orbit around the center of the Milky Way, about 2/3 the way out in the disk, and the full period of that orbit is about 250 million years. But there's an oscillation vertically called the Zmotion, sort of like imagining the Milky Way disk as a warped, old-fashioned phonograph record. Every 35 million years, the Earth and the solar system itself, and nearby stars too, pass in and out of the plane of the galaxy. In this denser region of material, passage through a denser region can trigger gravitational interactions, which, for example, can jostle the comet cloud, the Oort cloud, and lead to a higher impact rate on the Earth. And that's the mechanism by which mass extinctions could be triggered by passage through the plane of the Milky Way. At the moment, we're not in the plane of the Milky Way, so this mechanism is not operating right now and is millions of years away from repeating. But it seems through the history of life on Earth that we must have been through this cycle about 10 times or a dozen times, and it's likely to be associated with one or more of the mass extinctions in the Earth's history. If we look at time in religion, we see that for many religions in the primitive ancient world, prehistoric, before written records, we have cycles of time. They manifest often in cave art, rock art, or more modern paintings from descendants of these people. So we have the Aborigine dream time, cycles of time. We have Hindu cycles within cycles. Human cultures have often tethered their creation myths to the rhythms of nature and the cosmos. The historian Mircea Eliade called this the myth of the eternal return. In the Hindu culture, which I've become familiar with when I teach Buddhist monks cosmology, there are amazing numbers of cycles of time, and the time spans from a culture that put this in place thousands of years ago are quite amazing. For example, there's a time which is about 4.32 billion years, remarkably about 10% off the age of the Earth, which is called the day or night of Brahma. And there's even a larger time span called the Great Kalpa, or the life of Brahma, which is equal formally to about 1.2 trillion years. That's a very interesting time scale because it corresponds to the entire lifespan of stars in their active phase in the Milky Way galaxy before the Milky Way goes dark. So whether it's a coincidence or not, the Buddhist culture has had cyclic time, and the actual numbers involved quite closely match geological and cosmological time scales. Time without end is in the Kalachakra, the Wheel of Time, which was translated into Tibetan in the 11th century. In this cosmology and mythology, multiple world systems are created and destroyed continuously. There's no beginning and no ending. In fact, there is a cycle from emptiness to formation to a time called abiding and then destruction. So this is the cycle within which life develops, evolves, and is extinguished before another cycle will begin. And that's the end of this topic.